Imagine being minding your own business, swimming in a nice warm ocean, when suddenly a giant snake the size of a school bus swallows you whole. Well, this was the reality for the animals living in the tropical seas 60 million years ago, because that's when and where Titanoboa lived. Titanoboa is the largest snake ever discovered. And while other supersized snakes like Gigantophis garstani may give this ancient reptile a run for its money, Titanoboa still holds the title because it was also the longest. The species reached lengths of over 13 meters and weighed almost a ton. That's longer than a Tyrannosaurus rex and heavier than a walrus. But the discovery of Titanoboa's fossilized remains in 2009 in northeastern Mexico has revealed more than just the presence of a really big snake. It is helping scientists understand how an ancient tropical ecosystem functioned and offering clues as to how creatures today might adapt to a changing climate. The first thing that surprised researchers about Titanoboa was, well, its size. The only other animals that have ever come close to this are modern-day blue whales. But these marine mammals weren't the first to achieve such gigantism. In fact, Titanoboa was so long that it would have been able to swallow a crocodile whole. And fossils tell us that crocodiles were among the giant snake's last meals. Crocodiles today come in a variety of sizes, but back then there was only one species, and it was huge, around 6 meters long. That's the same size as today's American alligator. For a long time, people thought this modern-day gator was the largest crocodile that ever lived. But not only were the ancient crocodiles smaller than today's Titanoboa, they were also warm-blooded, or at least more warm-blooded than their cold-blooded descendants. Warm-bloodedness gives animals the ability to maintain a constant body temperature. And this allows them to be active in a wider range of environments and to grow larger than their cold-blooded counterparts. And while all living crocodiles are ectothermic or cold-blooded, meaning they rely on external sources like the sun to regulate their body temperature, some crocodiles from the late Cretaceous period were instead endothermic or warm-blooded, thanks to genes that allowed them to generate their own body heat. Researchers think these warm-blooded crocs were active predators, chasing down prey in the water. But despite their size and ferocity, they were no match for Titanoboa. These giant snakes could grow so large in part because they had a highly efficient way of circulating blood around their bodies. Thanks to this adaptation, they were able to move quickly, both on land and in water, allowing them to hunt and escape from predators like sharks. Sharks were another large predator in these ancient waters, and they too may have been warm-blooded. Today, most sharks are either around 2 meters long or larger. But 60 million years ago, there were many more medium-sized shark species, possibly, because warm-bloodedness allowed them to grow to a size that was larger than smaller sharks, but still small enough to conserve energy. So the ecosystem that Titanoboa lived in was full of warm-blooded, medium-sized predators, not to mention other large marine animals like turtles and mosasaurs, a type of ancient whale monster. But none of these predators were at the top of the food chain. Titanoboa was. These gigantic snakes were PEX predators, and PEX predators tend to be less abundant than their prey and often live in disparate habitats. In other words, they aren't very good at sharing resources. So why did so many different kinds of medium-sized predators coexist? The answer, according to researchers, is that the ecosystem that Titanoboa lived in was a tropical one. It was warm, it was wet, and it was full of plants with broad leaves that provided lots of shade. This meant there were tons of different niches available for medium-sized organisms, which is likely why so many different types of medium-sized sharks existed. What's more, there were plenty of resources to go around. The tropical ecosystem supported a huge population of prey animals, so no one had to compete too hard for food. Similarly today, tropical coral reef ecosystems support a huge diversity of medium-sized predatory fish. That is, if we can keep these ecosystems warm enough. One way that researchers know that Titanoboa lived in a tropical ecosystem is by studying the chemistry of the water where its fossils were found. This is because the temperature of the water where Titanoboa lived is recorded in the chemistry of the rocks. By studying the chemistry of the rocks where the snake fossils were found, researchers determined that the water temperature was around 30 degrees Celsius, definitely warm enough for a giant snake to thrive. And it turns out that today, as tropical oceans are warming up twice as fast as the rest of the world's oceans. As a result, some scientists predict that the tropics will become uninhabitable for the animals that live there today, including corals, sharks, and maybe even crocodiles. But by studying animals that used to live in tropical environments, like Titanoboa, we can get an idea of what animals today might do in order to survive. After all, evolution is just a long series of adaptations to environmental change. So who knows? Maybe someday we'll see a giant snake rule the seas once again. Thank you for watching this episode. I hope you liked it. If you'd like to help me make more videos about extinct giant snakes and other prehistoric creatures, feel free to like, comment, and subscribe my channel to support my work. See you next time.